and welcome back to the second presentation in the PyData track of the Python Web Conference. And with us now is Francesco Tisiot, who's a developer advocate at Ivan in Italy, and he is going to be presenting on using Apache Kafka and Python for streaming applications. So with that, over to you, Francesco.
Okay, so I believe you are all here for a Python conference, and you may wonder, why should you care about Apache Kafka since you are a Python developer? Why should you care about the technology since you want to write code? Well, let me tell you something. I believe you're all here and you are somehow Python developers. And you are either working on a kind of new shiny app that you just recently started working on and you are all excited about, or someone dumped on you an old rusty app and you have to maintain it, extend it, and do something with it. No matter what, new or old app, you will have within the app some communication, because I've never seen a piece of code, an application that works in pure isolation. You will have several components within the app that needs to talk with each other. Or you will need to communicate between the old rusty app and the new app. Well, let me tell you a secret. Apache Kafka is a tool that makes this communication very, very easy. Let's dig a little bit more in this time into the history. In the old days, we were all used to applications like a Python app that was somehow writing data to a backend database or reading data from a backend database. Most of the times, we weren't sending each record to the database or reading one record at a time from the database, but we were pushing data in batches or reading data in batches. And we were waiting a batch time that could be seconds, milliseconds, or minutes or hours. So this batch time was creating a delay from when the data was ready to be pushed to the database and when it landed to the database, or when it was in the database ready to be read by the application and when the data was flowing into the application. Now, this concept of batches and delay is not a reality anymore, because we work in a world where we have event-driven application. Event-driven application are applications that as soon as the event is created, they need to know about it, and they need to start reading, parsing, and pushing the result of their parse to downstream application. We need to do that immediately. We cannot wait a batch time to do it. And this is becoming the default for all our work. But we say that we have to create event-driven application. What is really an event? An event, we are all used to, for example, mobile phones, and we are all used to receive notifications. Notification is a manifestation that an event happened. So, for example, you paid with your credit card to purchase a new pair of shoes, or someone else stole your credit card to purchase a new pair of shoes. Even going out from this digital world, we were used to events even before. For example, when the alarm in the morning started singing, we were used to see that as an event and react immediately, because we were either waking up or we were snoozing the alarm for 10 minutes. But we didn't only receive events, we were also creating events. Going back to the alarm kind of analogy, if we changed the alarm time, we were creating an event that was going to create another chain of events. In these days of pandemic, we all have been using mobile applications and creating, for example, food orders with mobile application. All these settings, all these things that we do with our mobile phone create events. For example, we switch on our mobile phone, we open the app, we select the restaurant, we select which food we want to order, and that creates an event. The event is sent to the platform managing the event, which sends the order to the restaurant that has to create, for example, the pizza for us. Then they create the pizza, and the owner of the pizzeria then sends another event when the pizza is ready for our delivery. All this is a chain of events, and all these applications or person needs to react as soon as the event is generated. So why event-driven? Well, we need to understand that in these times, any information that is generated in the world has a lifespan. And the lifespan of certain information is so short that the information is useful only for 10 seconds, 20 seconds, 30 seconds. Let's take the example of the position of the delivery person. We couldn't care less about the position of the delivery person 5 minutes ago. The information about the position is useful only if from the time that is taken from the cell phone of the person delivering to the time that it lands on the map on our cell phone, we have a delay of 10, 20 seconds. After that, it becomes almost useless. And time is a constraint, and we will see time as a constraint even more in the future. So what is Kafka? I told you before that it is a tool that makes communication between components or between applications really easy. The detail, the reality of Kafka is that it's based on a very, very simple idea. The idea of a log of events. So event number 0 arrives and we store it. Then it arrives event number 1, 2, 3, and 4. It's append only. So it means that once we wrote event number 0, we cannot change it anymore. If something happens that change kind of the shape of event number 0, we record it as another event in our log. And the sequence is ordered. So because event 0 happened before event 1, we store it before event 1. Even on top of that, Kafka doesn't store events on just the memory. It flashes them to disk. So we have persistence of our data. It would be said that all Kafka was a management of a single log. We have a lot of events of different type. So for example, this first log where this sharp edges events is the food orders, pizza orders. Let's say that we have another set of events that is the pizza delivery position. We create another log for that, and we fill it with the exact details of the position of the pizza delivery person. In Kafka terms, those different logs are called topics, and topics are the way that I use to refer to a particular log within Kafka. So topic A will be the pizza orders, topic B will be the delivery position. Let's go more in detail about Kafka. Kafka, by default, is not just a monolith application. It's a distributed application. So this means that every time you create a Kafka application, you create kind of a cluster of multiple nodes. Those nodes, in Kafka terms, are called brokers. Now, the log information in Kafka is stored not only one time, it's stored multiple times across the brokers. As you can see here, I have 2 logs and I have multiple copies of this log. The number of copies for each log, each topic that I keep on Kafka is defined by a configuration called replication factor. In this case, for sharp edges log, I have replication factor of 3. For round edges log, I have a replication factor of 2. Why this is useful? It's useful because even if I lose a node, I lose a broker, I still have all the available data still there. I don't lose any log, any entry within the log. Let's look a little bit more in detail at this situation. Let's just go with one log, our sharp edges log. We have the sharp edges log distributed with a replication factor equal to 2. Let's say that now we lose a broker. What Kafka does, it understands that a broker went down. It checks the available topics around the remaining brokers, and it sees that we have the sharp edges topic with only one copy, but a replication factor of 2. And what Kafka does is starts replicating for the second time the topic sharp edges in order to have a number of copies in line with the replication factor. Once this is done, even if now we lose another server, the data is still available there. This makes Apache Kafka highly available and fault tolerant. So we understood the overall architecture of Apache Kafka, but what is an event for Apache Kafka? Well, for Kafka, an event is just a pair of key and value. Key and value that in Kafka terms are just a series of bytes and can go from very simple things like, I don't know, max temperature 35°C to something really complex like, I don't know, the as key, the shop receiving the order and the phone line used to make the order, and as value the order ID, the name of the person calling, the phone number, and the list of pizzas that this person is ordering. And the format could be JSON, Avro, or something else. It's up to you. For Kafka, it's only a sequence of bytes. How do you write to Kafka? Well, it's really easy. In this case, we are a Python conference, so we will use a Python application that, if it wants to write to Kafka, in Kafka terms, is called a producer. And it writes usually to one or more topics. In order to write to a topic in Kafka, all the producer has to know is where to find Kafka, so the list of brokers in terms of host name and port, how to authenticate to Kafka, so do we use, for example, SSL certificates, and how to encode the data from the format that I use in Python to the raw series of bytes that Kafka understands. That's it. On the other side, if I want to read from Kafka, I will have a Python application again that will be called consumer. And what the consumer does, it reads the event number 0, and it communicates back to Kafka, hey, number 0 is done, move my offset to 1. So next time it will send me the number 1. Once it reads also the event number 1, it communicates back to Kafka, hey, I'm done with 1, offset to 2. This means that also if my consumer is busy for a time or it falls down, Kafka knows until what point the consumer has been reading. So next time we'll probably send the item number 3 and move the offset accordingly. In order to read data from Kafka, all the consumer has to know is kind of the same information as the producer. So where to find Kafka, host name and ports, how to authenticate. And since before we were encoding data, now we need to understand, we need to know how to decode the data. The last thing that we need to know is from which topic or which topics we want to read from Kafka. So now that we understood both producers and consumers, I believe it's time for a nice demo. In order to do that, I created a series of notebooks that I will share with you at the end of this talk. And they are all based on Ivan managed data services. So the first notebook that I created is called Ivan Setup, is creating, let me show you, a Kafka environment on Ivan website and a Postgres that we will use later. I could do the same during the live by creating a new service. And with Ivan, you can create a good list of open source data platforms in a lot of different cloud vendors. And within the vendors, using almost all the cloud regions available within the cloud vendor. And then you can specify also the service plan that gives you the size of the environment and also drives the associated cost. But let's not wait for this. Let's use the pre-built instance. So first of all, we want to produce some data. So let's open the producer and we install the Kafka Python libraries, which we will use for our demo. Okay, this is installed. Now we create a producer. We create a producer and we say where to find Kafka, how to authenticate SSL using these 3 certificates, and how to serialize the data from JSON to the raw series of bytes. So we create the producer, it's created, and now we send the first message to Kafka. And it's sent here, but how can we verify if the message is really sent or not? We can start a consumer. There we are. It's the same thing as before. We have a group ID, and we will come to the group ID back later. We create a consumer, and we tell him, look, I want to connect to a certain host name and a port using the same SSL settings as before. And now I want to deserialize. Let me close this a bit. I want to deserialize using the opposite technique as I was using to serialize before. So let me create the consumer. As of now, we created the consumer, but we didn't tell to Kafka to which topic we want to listen from. Let's first check which topics are available in Kafka. I can check that, and I can check that I have some internal topics together with a nice Francesco pizza, which is the topic that I just created for this demo. I can now subscribe to the Francesco pizza topic and verify the subscription. And now I can start reading from Kafka. As you can see here, I'm starting reading, and this reading will never end. This is because it's pinging Kafka, and it will start reacting, in this case, printing the message as soon as the message is ready in Kafka. However, if you remember before, I sent a message, I sent an event, Francesco ordered a margarita, and I'm not seeing the same event appearing in the consumer. Why? Well, because by default, when a consumer attaches to Kafka, starts reading event from the moment that it attaches to Kafka. It doesn't go back in history. We can change the behavior, and we will see how we can change it after. But as of now, we don't see the first event. Let's now try to send another couple of events. Adele ordering a pizza Y is not a wise decision from my point of view. I don't like a Y pizza, but up to you. And Mark ordering a strange pizza with chocolate. Let's try to send them. There we are. We see immediately those events being propagated to Kafka and to our consumer. So the consumer actually works, is that we didn't start reading from the beginning of the log. Okay, we now understood how to produce and consume events. Let's go back to some more slides. Okay. Let's talk about the log and the log size. We understood that a log is stored in a node of the cluster, in a broker in Kafka terms. It would be pretty sad if we had to limit the amount of data that we could store in a log because we had these constraints on our nodes. We could only store, for example, logs or events for the size of the minimal disk in our cluster. Or we had to size our cluster to have enough disk to host the whole log of our biggest event type. In order to avoid this trade-off, what Kafka does, it offers an idea called topic partitions. Topic partition is a way to logically divide events of the same event type into different logs, which are part of the same kind of log. So for example, for the pizza orders, I could subdivide the pizza orders events into different queues. So for example, blue, red, and yellow. I could have, for example, the pizza orders divided by the restaurant receiving the order. So I could have Mario's Pizza representing the blue, Luigi's Pizza representing the yellow, and Adele's Pizza representing the red. This is just a way to subdivide events of the same type into partitions. If now we have a look at the same kind of diagram as before, how Kafka stores logs and partition is that the broker actually stores a partition or more than one partition. So this makes the partition the thing that defines the size of the disk, the limiting factor, is not the entire log anymore. So if we have a huge log with a huge amount of events, we just need more partition to host it in brokers with a smaller disk. So the log size is not a problem anymore. Again, we have redundancy of the partitions. And if you check here, the replication factor is 2 for all the partitions because the replication factor is defined at topic level. But even here, if we lose a node, we still have all the data for all both the blue, the red, and the yellow available from the other nodes. And as before, Kafka, in cases of failure, will start re-replicating the available information. We said that once we put data in Kafka, data is there forever. However, we can define for how long the data is useful to be kept on Kafka with the topic retention policies. We can say, please keep the data in Kafka for 6 hours, 2 minutes, 6 days, 20 days, also forever. Or on the other side, we could say, keep the data in this particular topic until the topic arrives to 10 gigabytes, and then delete the oldest chunk of it. Of course, if you use the size approach, you have a perfect knowledge about the size, but you lose control about for how long an event will be in Kafka. On the other side, if you use the time-based approach, you know exactly for how long an event will be in Kafka, but you lose notion about the usage of the disk. You can also use both, and the first bar here that will hit will be the one dictating where I will start deleting data. So how you select a partition? Usually selecting a partition is done during the producing side of things. You can either say with the producer, hey, I want to send this event to this precise partition. So I want to say the event Francesco ordering a pizza margherita to partition number 0, or usually is determined by the key. The key is usually hashed, and then based on the result of the hash of the key, a partition is chosen. This makes a rule that every record, every event having the same key will end up in the same partition. The third option that you have when selecting a partition is to send a message with null key. In this case, it will end up in a random partition among the available. Why selecting a partition is important? It's very important because of ordering. Let me show you a quick example. We have our Python producer that produces data to a topic with 2 partitions, and then we have a consumer. Let's say for our small case, we have 3 events, a blue one, a yellow one, and a red one. When we produce the data to Kafka, the blue event, the first one, will end up in partition 0. The yellow one will end up in partition 1, and the red one will end up in partition 0 again. Now, when we read the data from Kafka, we could end up in a situation like this. First, we read the blue event, then we read the red event, and then we read the yellow event. As you can see here, those events are not ordered globally in a correct mode, but if you check the ordering per partition, they are in the correct order. Because for partition 0, blue becomes before red, and it's correct in the resulting series. And the same for partition 1, where we have only a yellow. Once you start using partitioning, you give up on the global ordering because Kafka ensures the correct ordering only per partition. So we understood that partitioning is good because allow us to control better the disk usage. Partitioning is also bad because we have to give up on global ordering. And in this case, we need to ensure that all events for which we care about the related ordering will need to end up in the same partition. Otherwise, we will have problems. But then also, partitioning is good because now, instead of having one unique log and one unique thread that tries to write to this log, we can have multiple threads, one per partition. So we can scale out, we can create multiple instances of the producer that will start writing data to the multiple partitions. And on the other side, I could have also multiple consumers. And both those 2 consumers, in my small example, will ask to Kafka, I want to register to this topic. What Kafka will do, it will assign a non-overlapping subset of partitions to each consumer. So for example, in this case, Kafka will assign the blue partition to consumer 1 and the yellow and red partition to consumer 2. In this method, Kafka ensures that all the events are being read by a consumer, and on the other side, that none of the event is sent to two different consumers. So it's read 2 times. This also makes easy in case of a consumer somehow dying, losing connection with Kafka. For example, consumer 1 goes down. Kafka will somehow detect that consumer 1 goes down, at a certain point redirect all the blue events to consumer 2, always ensuring all events have been somehow consumed. So we understood that partitions are useful. Let's check out another demo. Going back to our notebook, let's now open the partition producer. Okay, we are now creating another producer just for the sake of creating new producer. And now with Kafka admin client that is connecting to Kafka and enabling us to do some administration part to it, we create a new topic called Francesco Pizza Partitioned. The interesting bit is this: we create the topic with 2 partitions, and in this case, since we really don't care about the replication, we use a replication factor of 1. Okay, let's create the topic. The topic is created, and now I want to create with you 2 consumers, 1 per partition. So let me create consumer 1. There we are. We create consumer 1 here. And now if we check how we assign the first consumer, is we tell to Kafka, please assign the consumer to the partition number 0 of the topic Pizza Francesco partition. So we assign the consumer only to read data from 1 partition. Okay, let me also create a new consumer, which is called, guess what, partition 1, and has kind of the same logic as the one assigned to partition 0. In this case, the only change between the top one and the bottom one is that the first one is assigned to partition 0, the second one is assigned to partition 1. I could have Kafka handling the partitions to consumer assignment. In this case, just for demo purposes, I'm fixing the partition. Then we can go back to our producer and we can produce 2 events. The first one, Frank ordering a pizza margherita on partition 0. The second one, Adele ordering a pizza Y on partition 1. If everything works well, we should see a line on the top consumer and a line on the bottom consumer. Let's check this out. There we are. The first consumer is reading from partition 0, offset 0, so it's the first record, Frank ordering the margherita. The second consumer is reading from partition 1, offset 0, name Adele ordering a Y. If we now insert a couple more, it still works. 1 record at the top, 1 record at the bottom. So we are able to push that to a specific partition and to read from a specific partition as well. Let's go back to slides. Okay. Now, so far what we saw was a really linear case where we had 1 or more threads of an application producing data and 1 or more threads of an application reading data. And those threads were working one against the other to read the whole set of messages, but only once. Let's say that this consumer is, for example, our 2 pizza guys making the pizza. So they have to read the pizza order topic, and every time they receive an order, one of them will have to make a pizza. So they are working one against the other to make all the orders, but they don't want to make the same pizza twice. But once we read an event from Kafka, that event is not deleted from Kafka. So it's available for other applications to read it. So let's say that in our pizza example, we have also the person doing the billing. And this person wants to receive a copy of all the orders because it has to create the bill. In this case, we have different applications that every application wants to read the same data at its own pace. How can we handle that in Kafka? With a concept called consumer groups. I can define the 2 persons making the pizzas as part of the same consumer. And then I can define a new consumer group with a new consumer in it that wants to receive the same data from Kafka. and Kafka will send another copy of the same data to him. And the good bit is that it will keep offset for each of the consumers and each of the consumer groups. So in case there is a crash of one of the consumers, Kafka will also know until which point the consumer group has been reading the data. So now that we understood what consumer groups are, let's check out another demo. So we go back to our notebook, and now let me open the consumer group over here. Let's go back to our initial consumer. In our initial consumer, we attach to Kafka after we produce the original event. So we only check out event ID 2 and event with ID equal to 3. Now we want to create a new application that attaches to the same topic and reads the data from the beginning. So what we do is we define the new application being part of a new group ID. The group ID is my new pizza group compared to the old one that was my pizza group. And even more, we attach to Kafka and we tell Kafka, please send me all the data since the beginning of the log with the setting auto offset reset equal to earliest. So if now we execute this piece of code, it's connecting to Kafka and should be retrieving all the data. And if you see, compared to the previous run, we attach to Kafka, we receive a copy of the same topic, but we receive it from the beginning. So we have also the message with ID equal to 1. If now we send another event done ordering a pizza with fries to the topic, we receive that on both, because for Kafka, those two are two different applications trying to read both a copy of the same topic. Okay, also this should be clear. Let's move on. As of now, we saw that we need a Python or a code, some sort of code in order to produce data to Kafka and some sort of code in order to read the data from Kafka. In the reality, we will start using Kafka in environments where we will probably already have data sources and data platforms where we want to push the data from Kafka. How we can do that? We don't want to reinvent the wheel. We don't want to write code every time. We can use a framework called Kafka Connect. With Kafka Connect, you can easily integrate with existing data sources, for example, with JDBC databases, with Google PubSub, with Cassandra. And you can also push data that is in Kafka easily to other data platforms, for example, Elasticsearch, Amazon S3, any JDBC data source, including Postgres, BigQuery. This Kafka Connect method, which is driven only by a config file, allows us to evolve existing application. So if you remember before when I was talking about a Python application writing to a backend database, maybe we want to include Kafka in the picture in order to create an event-driven application or a chain of event-driven application. But we don't want to change the working code. We don't want to change the app to database design. How can we include Kafka in the mix? Well, we can use Kafka Connect and change the data capture solution that will start listening to any change in a table or a set of tables in our database and propagate those changes into a Kafka topic. Kafka Connect is not only useful to source data from existing datasets, but also to distribute events and data which are in a topic in Kafka. So if we have our Python library, our Python application that is writing to a topic in Kafka, or we have some data in Kafka, with just a config file and a thread or a series of threads of Kafka Connect, we can distribute those messages to any JDBC database, including Postgres, for example, to BigQuery, if we have another team that wants the data in BigQuery, or to Amazon S3 bucket that we want to use, for example, for long-term storage. And the beauty of this is that it's only driven by a config file. It's very, very easy. So now let's look at the last bit of the demo. And in this case, I will also use part of Ivan, which allows you to have Kafka Connect as a managed service. So you don't have to create your own instances of Kafka Connect. So let's go back to my notebook and let's open the Kafka Connect one. And let's close all the other notebooks that I don't need anymore. So I'm creating a new producer again, because I like creative producers. For this final example, I'm not going only to send the data as only, for example, Francesco ordering a margarita, but I'm also sending, together with the message, the schema of the message itself. This makes Kafka Connect life easier because it allows Kafka Connect to parse really well the message and push the output of this parsing to another data platform that in this case will be a Postgres database. So we can define the schema of our data by saying that the key is made by a field call ID that is an integer, and the value is made by two fields, one called name, which is a string, and one called pizza, which is another string. So if we run this, that's okay. Now we can send the data, and as I said, I'm sending to Kafka both the schema and the payload. So I'm sending the schema with the key schema and the payload id equal to 1. The same for the value schema. It's a value schema, and the payload, it's Frank ordering a margarita. Then we will have Dan ordering pizza with fries and Jan ordering pizza with mushrooms. So we send the data to Kafka. Now, I told you that Kafka Connect is basically, you need only a config file in order to start distributing events in Kafka to other data platforms. So let's check my config file and let's check my Kafka Connect setup. This is my setup. And as you can see, all I need to define in order to create Kafka Connect, to start using Kafka Connect, is this JSON structure, where I say, please create a Kafka Connect with sync Kafka Postgres name. Take the Francesco Pizza schema topic from Kafka and start propagating it to using a JDBC sync connector to this Postgres database, where I say this is the host, the port, and the database, using a really secure new PG user with a really secure password. The last bit that I'm saying here is that look that the value that you need to convert and to push to the Postgres database is in JSON format. And if the target table in Postgres doesn't exist yet, please create it. So I can copy this JSON. I can go to Ivan. I can go to my Kafka PyWebConf, go to the connectors and create a new connector. I will create a new JDBC sync. Sync is the term where I want to push data that is in Kafka to downstream data platform. And I could fill all the fields here, or I can simply edit and copy paste my JSON format. This will be understood by Ivan and will fill all the parameters for me. Now that all the parameters are filled, and as I told you before, I have the connector name sync Kafka Postgres, which is taking a JSON value coming from Francesco Pizza schema, and is pointing to the same database that I was telling you before. And on the DDL support, if the table doesn't exist on Postgres, it will create it automatically. But because I don't want you to think I'm lying, let me show you on the Postgres side. I have a connection to this database with a default DB. There's a schema, public schema. Under the tables, there are no tables. Let me now create the Kafka Connect. So the Kafka Connect, I believe, let me show you here. You can see now that I have a task called sync Kafka Postgres running in running state. If now I go back to my database and I refresh the tables here, I can see a Francesco Pizza schema table, which has the same name as the topic. If I double click on it, I see the 3 rows that first I sent to Kafka. So the Kafka Connect automatically created the table and start populating it. Even more, I can send another event to Kafka, and immediately on the other side, it's happening. So also Giuseppe ordering a pizza web is there. So let's go back to the final slide. We understood that how we can, what Kafka is, what Kafka solves, how to produce data to Kafka, how to consume, what partitioning is, how can I use Kafka Connect, and how I can create several applications reading the same data by defining new consumer groups. In order to close this session, I want to give you some references. The first one is my Twitter account. If you have any question or if you want to know more about any of the technologies that I've been talking to you about today, just reach out to me. My direct messages are open. If you want to access this set of notebooks, I created them and they are open source in GitHub. If you want to test Kafka, but you don't have any data source, I also created a fake pizza order Python application that you can use, and it creates pizza orders with a lot more fields than the chew that I use today. And if you want to try out Kafka, but you don't have Kafka, well, check out for Ivan.io, because we provide that as a managed service, and you can redeem the $300 of free credit that you can use within the first month to start your trial. And by the way, since I'm talking at the Python conference, we are also hiring a lot of Python developers. So if you want to work for a startup that is in the middle of a cool data technology and Python coding, well, just reach out to me and I will be more than happy to talk to you. And now I'm here for all the questions that you might have. Thank you very much.